Now today's experiment is to compare the EMF of two primary cells by using potentiometer. Now for this experiment, apparatus requires a potentiometer, Leclanche cell, Daniel cell. These two cells are the primary cells. An ammeter, a voltmeter, rheostat, galvanometer, eliminator. This is the power source. In this place of the eliminator, we can use battery also. A one-way key here, a two-way key here, and the connecting wires. For this experiment, we should know the theory. First of all, we know here E, the EMF of the cell is directly proportional to the length. For the first cell, we can say if length is L1 for the balanced condition, then we will say E1 where it is L1, then E1 equals to KL1, where K is the proportional constant, and this constant is also known as the potential gradient. Somewhere it is also known as the potentiometer constant. For the second cell, similarly for the second cell, E2 where it is L2 or E2 equals to KL2. K is the same in both cases, that is the potential gradient. Here K is the potential gradient. Now dividing this equation by this equation, E1 by E2 equals to L1 by L2. This is our working formula of the experiment. Now come towards the circuit diagram. This is here the potentiometer. Here are 2 points of the potentiometer, 2 ends of the potentiometer, and this may be here, this wire, this wire, this wire, and this wire. It is in the length of 1 meter. So there may be here 1, 2, 3, 4 wires, but in the laboratory we have the potentiometer having 10 wires, means total length from P to Q is the 10 meter. A is the ammeter, here it is C. This portion is the primary circuit. It is positive, negative, one-way key, and ammeter with rheostat. And this circuit is connected to P and Q. This is also known as the primary circuit. Now comes towards this. This is the positive of this, positive of cell. So it is positive. Connect this one cell here now, positive to positive, and another cell positive to positive. At this end there is two-way key, and through this key one rheostat is attached, and from this 2000 ohm is taken out to save this galvanometer, so that no extra, no more current will flow through the galvanometer, and in keeping this 2000 volt and 2000 ohm resistance in the resistance box that protects the galvanometer to be damaged. Now we will see, we will do the experiment. First of all, we will connect all the apparatus. Now see here, this is the potentiometer and this is the power supply voltage. We are now battery eliminator. Positive of voltage, this is of eliminator is connected to rheostat, and another end is connected to the milliampere meter, and second is connected to the here. So positive is connected to this positive. This is made positive. Now this is here one cell, this is here the other cell. The positive of these two cells is connected to this point. Another point negative which is connected to here now with a two-way switch. Now it is one end of the two-way switch is connected to this rheostat, and from this rheostat 2000 ohm is taken out so that this has resistance at least 2000 ohm to save this galvanometer. Now another galvanometer is connected to this jockey. Now we will supply here the power. Then after we will plug in one cell and we will check first then our connection is correct or not. Then we will put one end here, the jockey, we will see the deflection in the left side, and here now again at the another end deflection is right side. So this means that our connection is correct. Now we are going to find out its resistance. The null point. So first of all, keep this rheostat at the 0 position or minimum position here, so that this gives the maximum current. Now we have kept here now at the near about 0 position, and we will take the reading in the ammeter here, that is, and we will find the null point here. So we will see putting here, and here. So in this wire we will find the value of null point here. This is here near about start 0 point is this, starting from here 100, 200 and 300, and here now it is 58 and value is there. So 358. Now for the second one we will do for the second cell for the same current. Now we will see this is here, this side, and now moving this side, jockey is here, now moving this side. We will find some null point on the galvanometer. On this one we will try to find out null point. Here is null point 217. So in the first case I found that 358, and for the second cell we found 258. Now we have repeated the experiment. For the first observation we will find for the 60 milliampere 358 271 for the E2, and its given by E2 is 1.62. Similarly we have taken the another two observation for 50 milliampere and 40 milliampere, and we will find this reading. Here is now that observation. The voltmeter, range of voltmeter is given, EMF of the arrhythmeter is given. Now one more thing. Here is it is 1.4 and it is 1.3, 1.12. This is here EMF of the Karachi cell and Daniel cell. We will fill this and make the table, and after that we have to take some precautions here. So those precautions are very important. First of all, that voltage EMF of the primary cell is always more than EMF of the experimental cell, and other one we can see that here that all the connection should be very tight. Okay, now I think